problems of the system. So we try to make some problems, but probably some of them are not correct. So even when we do our best with those problems, the final product could be wrong because we solved the wrong problem. Okay, so determining the problem right is very important in system analyzing and design. We try, when we want to analyze, when we do analyzing any requirement document, we try to determine, to notice, to get the problems exactly. We try to detect problems right. Okay. And in the designing phase, we try to solve those problems correctly. Both of them should be correct, should be right. Either the problem or the solution. Both of them should be correct. The first phrase focus on determining the problems of the system correctly, and the second phrase tries to say that we should solve the problems correctly. So these two phrases are different, and both have equal importance in software engineering. So now we want to analyze or gather the requirements from the users. We try to define problems right. And when we turn down to design phase, we start to trying to solve the problems correctly. We try to make correct solutions at the design phase. I think it is clear enough for you. During the analysis stage, systems designers focus on understanding the requirements document to produce a high-level specification that describes what the system is supposed to do. What's the meaning of high-level It's excuse me, can you hear me? Yes, yes. My connection was lost for a moment. Yes, now can you hear? I share my desktop again. No problem. Excuse me. Uh, my connection was lost again. Uh, my phone was rang. Let me for a moment. Excuse. I'm sorry. Excuse me. Let me share again my screen. Okay. I said that the system analyzers in the analysis stage focus on understanding the requirements document to produce a high-level specification. How we will do a high-level specification? How we specify requirements in a high level? Which language could be used to specify to have a high-level specification? As I told you before, we use a UML language, Unified Markup Language, Unified Modeling Language, excuse me, to prepare, to provide a high-level specification of user requirements. And we have several diagrams to specify requirements of our users. So in the analysis diagrams such as activity diagrams, sequence, use case diagrams, class diagrams to show users requirements at a high level specification. Okay, that describes what the system is supposed to do. The output of the design stage, the output of the analysis stage is some models, some diagrams which was made by UML notations, but the output of the design stage is our solution for that system, for the system under consideration. Okay, so the output of the design stage is a design specification. The design specification specifies our solution. Okay, so the output of the design stage, a design specification should specify clearly how the system should be constructed. Exactly, this tell us that which is our solution. Our solution tells us how the system should be constructed to satisfy requirements, user requirements. Okay, so it's clear for you what's the output of analysis stage and what's the output of design stage, and what we should to do in the analysis stage, and so that for design stage. In other words, we in design stage we focus on solution space, but in the analysis stage we focus on problem state, problem space. Okay. The UML2 standard specifies certain diagram types for documenting the system models. As I told before, the UML stands for Unified. U is for Unified Modeling Language. There are several notations for classes, for branches, for relationships, for inheritance, for part of, for composition, aggregation, and so on. It includes some graphical notations that specify entities of our system under consideration, and the relationship between those entities and so on. Okay, so is to be documented by UML diagrams, and we give to developers to program each of these diagrams. This means this 13 diagrams models a distinct characteristic of systems structure or behavior. Some of these diagrams specify the structure of the system, but others specify the behavior of the system under consideration. 6 diagrams relate to the system structure, but the remaining 7 diagrams are related to the system behavior. Okay. In this case study, specifically, in this case study, we will only focus on class diagram. Class diagram is one of these 13 diagrams that could specify clearly the system under consideration, the structure of our solution. Okay, so the first thing to do in analysis state in this case study is that extract classes of the system. As I told, by lexical analyzing of the requirement document, we could simply determine some of those classes. Okay, which model the classes or building blocks the classing blocks of the system. Okay. By determining our classes, we make a list of building blocks, and we can give the developers the definition of each class to make a program. Okay. This slide focuses on how we can identifying the classes in a requirement document. This is the same those guidelines that I remarked before. The first item said that we should identify the classes that are needed to build the system by analyzing the nouns and noun phrases. We should determine the nouns and noun phrases from requirement document that appear in the requirement document. The nouns and noun phrases are candidates for making classes of the system. Some of them are our classes, but others could be attributes of our classes. We may decide that some of these nouns and noun phrases are actually attributes of other classes in the system. I told this before. We may also conclude that some of the nouns do not correspond to parts of the system and thus should not be modeled at all. Probably this could be happen in any system. Some of those nouns may be not a class, not classes, or not attributes at all. So there is no need to model them at all. For example, in this list, let me see. For example, in this list, as you know, the bill is a noun, the cash is a noun, but there is no need to model these nouns at all because they are no class, they are no attribute of other class. So we don't model these nouns at all. We just try to model the classes of the system and assign them their attributes. Okay. Some of these concepts are familiar for you probably because in programming languages in previous degree you have learned probably about object-oriented programming, and maybe you have implemented some object-oriented systems. And if you have industrial experience, they are trivial for you. But if not, you should learn about them in this course. Okay, let's go. Additional classes may become apparent to us as we proceed through the design process. All of the classes that are needed to design a system could not be determined from the requirement document. But some of the needed classes may become apparent through more analyzing activity. For in when we investigate the system with more details, some new classes may become apparent. So in the first stage. In the lexical analyzing stage, we just can determine some of the needed classes, not all of them. Some of them may be postponed to later phases of development life cycle or of design activities. So the primary classes could be determined by lexical analysis and determining nouns and noun phrases. Some utility classes are needed that we should design them when we want to implement the main classes or before the implementation phase. Identifying the classes in requirement document, we create classes only for the nouns and noun phrases that have significance in the ATM system. As you know, some terms such as bank, such as screen, such as bank database, such as customer, such as account, all of these nouns that I told you are significance nouns. But some others such as PIN, such as cash, such as balance, such as account number are not so significant. The account number, for example, is meaningful when we have an account. If we have not any account at the bank database, or we have not defined any account class for the bank database, the account number could be meaningless. So in lexical analyzing phase, we should focus on nouns and noun phrases that have significance in the system under consideration. So the requirements document frequently describes transaction in general sense. We do not model the broad notion of financial transaction at this time. Later, in next part of this designing activity, we consider transaction as a class, but for now we don't consider the transaction concept as a class, because now we have balance inquiry, withdrawal and deposit as some classes which make our transactions, our different transactions. In this case study, we have defined 3 types of transactions. The first one, as I told before, is balance inquiry. The second one, withdrawal cash. And the third one is deposit, the deposit transaction. So at this time, we don't model the transaction as a class, but later in the next part we consider this concept as a class, and we will define 3 subclasses for its 3 types of transactions that I mentioned. As you see in this slide, instead transaction, we model 3 types of transactions: balance inquiry, withdrawal, and deposit as individual classes. These classes possess specific attributes needed for executing the transaction they represent. We could determine the attributes of the candidate classes by analyzing nouns again from requirement document. Let me see your message. I have got one message. All of you have a problem with my son. You can hear me? No? Okay, okay. Mr. Muhammad, probably your net have problem because Miss Fadia has no problem with my son. You can check your net, or you can refresh or log out and log in again to the system to heal your problem. Why, Miss Fadia? Can you take a list of them so that I will contact with Dr. Rahmani to help them? Oh, net is bad. No problem. I think, excuse me, I have not taken any record for this session. If you have taken a record from this session, you could excuse me, I forgot to take a record. For this session, now it will be incomplete if I take a record now. It will be incomplete. If some of you have taken a record, you can share it with your friends. And I'll send you again another part of the Dr. Sanati video about this lecture. He talks more fluently, and you can got the course more easier by looking at those videos. So let's go ahead. All classes that we can identify by lexical analyzing of the requirement document are listed in this slide. These nouns that we mentioned before have specific have significance at the ATM system. So all of them could be our classes. We should define an ATM class, screen class, keypad pad class, cash dispenser, deposit slot, account, bank database, balance inquiry, withdrawal, deposit. All of these nouns have significance in this system, so we should define them as individual classes. Okay. So next, we want to identify the attributes and methods of these classes. To identify the attributes, we again should analyze should review the requirement document for other nouns or noun phrases that could be that could specify these classes. Any attribute, any noun phrases in the requirement document which specify some of these classes could be an attribute of those classes. Okay, and to identifying the methods of these classes, we should again review the requirement document to extract verbs and verb phrases. Verbs and verb phrases probably are methods of these classes. Okay, so we should go ahead through requirements document to with mark the verbs and verb phrases and list all of them, and determine the subject of each verb. Each verb could be an attribute of its subject. Okay. The UML enables us to model via class diagram the classes in the ATM system and their interrelationship. It is trivial for you. Figure 12.6 represent ATM class. The primary class diagram for this ATM system is showed later in this slide. This is a part of our class diagram in which some of our classes are modeled in this diagram. This is a specific class diagram which remark that an ATM class includes some other objects such as a screen, such as cash dispenser, such as keypad and deposit slip. And for simplicity, in class diagram, we model each class by a rectangle in which the name of the class will be written in the center of the rectangle. Okay. But in extended form of the class diagram, we should define a rectangle with 3 parts for each class. This is a UML notation for class. Each class could be modeled by this notation. In the first compartment of this rectangle, we write the name of the class. In the second or middle compartment, we should list all attributes of this class. And in the third one, we should list all methods of the class. Okay, so we use this notation to show each class in our class diagram in UML diagrams. Okay. So as I told, each class could be modeled as a rectangle with 3 compartments. The top compartment contains the name of the class. The middle compartment contains the class attributes, and the bottom compartment contains classes operations or methods of the class. Okay, such as you saw in this slide. The class diagram also showed the relationships between classes of the system. As you saw in this slide, we are some relationships between these classes. An ATM class has a relationship with a screen. Each ATM machine includes a screen, and each screen is related to one ATM machine, and so on for cash dispenser, keypad, and deposit slot. So we define the relationship between each two class with a solid line, probably with some shape at one or both ends of this solid line. This is a simple association between the class ATM and withdrawal. Each ATM machine at the moment executes 0 or 1 withdrawal transaction. Okay. As you remember, if you remember, we mentioned in requirement document, for simplicity, we suppose that ATM could not execute transaction in parallel or concurrent manner. Okay, so in this class diagram, we define that each ATM machine can execute up to 1 withdrawal transaction at a moment, at time. Okay, so let me see. Figure 12.7 show our classes ATM and withdrawal relate to one another, as you saw here. This is figure 12.7. And notice that the rectangles representing classes in this diagram are not subdivided into its compartments. This is for simplicity. This is for simplicity. In this diagram and other class diagrams, we just show each class by a simple rectangle, and we don't show its internal compartments. Okay. The solid line that connects the two classes represents an association relationship. An association relationship. This is an association relationship. We have other types of relationships, such as is-a relationships in object-oriented, such as part of relationship. But in this case, we have an association relationship. Okay. In association relationship, the classes at the two ends of this relationship relate to each other by doing some behavior, some service for the other class. For example, in this case, the ATM class can call any method of withdrawal or can call the executes method of withdrawal class. Excuse me, let me a moment. Okay. The numbers near each end of the line, the solid line, are multiplicity value, which indicate how many objects of each class participate in the association. As I told you, at this end we saw the number 1, but at this end we see the number 0 to 1. This means at each time the maximum number of withdrawal classes that are related to an ATM machine could be 1. We have no more withdrawal execution or withdrawal transaction at the same time, more than 1. Okay, these numbers define the multiplicity of this relationship, which means at most 1 withdrawal class could participate in this relationship, and in this relationship we have exactly 1 ATM machine. Okay. I told you about this item, and let me skip it. Figure 12.8 lists and explains the multiplicity types. There are several multiplicity types in system analysis and design techniques. The meaning of them are trivial, and there is no need to talk more about them. Some of them that I want to remark is the star mark. The star mark, the meaning of the star mark is any non-negative integer, 0 or more instances of the class can participate in an association. Or 0 to star means 0 or more. This is identical to the star mark, but this is different from previous 2 marks. This starts with 1 or more, but this is 0 or more. Okay. Association can be named. Each association could have a name, such as this one, as you saw. The name of this association is executes, and this name implies that an ATM machine want to execute any withdrawal transaction. Okay. The word executes, for example, I told about this. Association names are directional as indicated by the field arrowhead. The association could be directional, as you saw in the this is a different association. This is a different relationship used in this class diagram. As you saw in this slide, you see in this slide, this is a composition relationship. This means that the ATM machine includes 4 parts, has 4 parts: screen, cash dispenser, keypad, and deposit slide. All these parts altogether make an ATM system, an ATM machine. So we name these relationships as has a relationship. We say that an ATM has a screen. An ATM has a cash dispenser. An ATM has a keyboard and a keypad. An ATM has a deposit slot. So we named this relationship as has a relationship. And at the other hand, we can say that deposit slot is part of an ATM. The keypad is part of an ATM. The screen is part of the ATM. So the part of and has a is the opposite together. When we investigate from the general class to the partial classes, we say we use has a relationship. But when the point of view is reversed and we read, for example, from the screen class to the ATM, we say that the screen is part of the ATM. Okay. The part of and has a relationship is showed by this notation, by this shape. Okay. And the multiplicities of this relationship are written at the ends of these relationships. All of them has one-to-one relationship. One ATM, an ATM has one deposit slot. One ATM has one screen. One screen could relate to only one ATM at the same time. Okay, they are meaningful. Figure 12.9, the solid diamonds attached to the ATM classes association lines indicate the ATM has a composition relationship with classes. Please note that these diamonds could be located at the end of the relationship which connect to the main class or general class, and the other end has no any shape. Okay, composition implies a whole part relationship. The ATM is a whole part, is a general part or whole part, but these classes, each of these classes are a part of the whole. The class that has the composition symbol, the solid diamond, on its end of the association line is the whole class. In this case, the ATM is the whole class. And other classes, the classes on the other end of the association lines are parts. So you should know parts and whole in composition relationship exactly. They are meaningful. If you specify the classes exactly, correctly, you can use some tools, some automatic tools, some case tools to generate a skeleton code from this diagram. As we will see in future session, we will introduce you an algorithm to generate the skeleton code of these classes from class diagram. The related algorithm is very clear and very simple. So if you have a good design, you have a clear and correct class diagram, you can generate the code for the system. You can implement the system more easily. This slide shows the class diagram for the ATM system. In this class diagram, some classes are presented such as ATM, deposit slot, keypad, cash dispenser, screen, as you saw in previous slides. and these relations is defined for you in previous slides. There are some new relationship between withdrawal and cash and other classes such as screen, cash dispenser, keypad, and deposit slot. For example, when a withdrawal transaction executed, there is need to show some messages by screen to the user or customer. So we should define an association relationship between withdrawal class and screen class. And this is the same for other classes. For example, when a withdrawal transaction should be executed, there is need a cash dispenser to dispense cash to the user. So we should define an association relationship between cash dispenser and withdrawal class. On the other hand, to execute a withdrawal transaction, we need to contact with bank database class and request the bank database class to execute the withdrawal transaction. And this class should read the account, the related account to this withdrawal request, and reduce the balance of the account according to the requested amount of money defined by the withdrawal class, and overwrite the balance to the account, then give a permission to the withdrawal to pay a cash by cash dispenser to the user. Okay. On the other hand, we can see some other relationships between ATM and database, bank database, and bank database with account. Both of them are trivial, and there is no need to talk more about this relationship. For example, when the user wants to enter to the system, to the ATM system, the user should be authenticated. As you know, by the requirement document, the user should provide an account number and PIN number. The ATM should connect to the bank database and call the authentication method from bank database. Provide an account number and PIN number and send them to the bank database to authenticate the user. If the user successfully authenticated by the bank database, the ATM is permitted to show a main menu to the user. But otherwise, the ATM should prompted a properly message by the screen to the user to make more attempts to log in. If we have 3 times invalid logging, the ATM should freeze the card. Okay, because the card may be stolen. So the ATM should freeze the card and give the user proper message. Okay. I talked enough about these phrases, these items, and I think there is no need to talk more about them one by one. You can see all of these items in chapter book that I have sent you. And if you have any question, you can ask your question in next session. Let me see the time. The time is over, and We have no more time. I want to summarize this um, lecture as you see in this slide. Okay. In this slide, the attributes of and operations of the classes are remarked. So as I told you before, you should review the requirement document to gain the attributes of the classes and the methods, which are verbs and verb phrases. In this figure, you see noun and noun phrases that are related to uh, each of these classes, so they can specify these classes. They are attributes of these classes, and you can add them to the class diagram at its compartment, and so on. You can do this for methods. Let me see. In these class notations, you can see more attributes and methods for each class, and you can find them in the chapter book that I've sent to you. As you know, we have no time, so I want to tell nothing about them. Please check the videos that I have sent you, and if you have any question about the video, you can ask your questions again. Oh, excuse me, I'm sorry, my screen was not shared for you. I've shared it before, but I think my connection uh, had a problem. Excuse me. Please don't worry about these problems now, because I have sent a good videos to you, and by watching those videos, you can got all of these concepts from those YouTube videos. So if you have no question, let me to finish this lecture. Mr. Muhammad, we sent you several messages about this. Excuse me, when I shared the screen, I switch to the PowerPoint slide, and I don't got your messages. To see your messages, I should stop share screen and switch on the LMS, the Adobe Connect page. Excuse me, I don't notice your messages. You can use your mic at these situations. Please, if you have a problem with my screen, my slides, or my sound, you can use your mic to remark me. Thanks a lot. I appreciate you for your attention, for your attending to the class. See you later. Bye for now.